So hi guys, welcome to this video. In this video, we'll be solving the Codeforces 706b, that is the interesting drink problem. So this problem basically states that a person wants to buy a famous drink from n different shops in the cities, and at each day he has X icons, and he wants to find out how many drinks can he buy from different shops. So So his plan is for Q consecutive days, he wants to buy drinks from different shops using M coins. So the input states that first line is single integer n, which is the number of shops in the city. The second line contains n integers, which is the prices of the bottles of drink in each shop. And third line contains an integer q, which is the number of days he plans to buy the drink. Then there are q lines following each number m, which is the number of coins he can spend that day. So we need to output the total number of shops where he can buy the bottle of drink from. So some example input and output is given for one of the test case. So moving on to the approach and solution of this example problem. So as you can see, initially we have n equal to 5 and prices of bottle in 5 different shops are given here, and it is given he needs to find it for q consecutive days. So at first day, he has coin of value 1. So on searching through this all the shops, there is no value which is less than 1. So he can buy a total of 0 number of bottles. Hence for first day it will be 0. For second day, he has coin of value 10. So for 10 he can buy from shop 3, 6, 8 and 10. So he can totally buy it from 4 number of shops. So output here would be 4. For the third day, he has 3 number. So with value 3 he can only buy from one shop. So the answer here would be 1. And for similarly for 11, he can buy from all of these shops as his value is greater than equal to the price of the drink, and so the answer would be 5. So one thing which comes to the mind here is for each consecutive day, he has to find how many number of bottles are less than equal to this price, and that is the answer for our each day. So for that, what he needs to do is he needs to traverse the array every time for every day to find total number of bottles. First he'll check whether 3 is less than 1, 10 is less than 1, 8 is less than 1, 6 is less than 1, 11 is less than 1. Then he will give this output as 0. So one thing to optimize this solution further is to initially sort this array. As you can see on solving each side, we'll understand that we need to get the sorted array to find the number of shops more efficiently. So what we'll do is first we will sort the prices of drink, then we will run the loop q times, and to find the total number of shops, instead of traversing linearly from index 0, we will apply the binary search approach to find the index of the position where value is less than the shop price bottle value. So we will run the loop, and for each consecutive day we'll apply binary search so we can find the index, and that index would be the answer. So for this 10 number from this array, first it will go to 8 position, then it will go to 10 position, and once it will find the 10 position, it will output its index as 4, and that would be our answer. Similarly for this one, it will go here, then it will go here, then it will go here, and it will output 5 as the output. So looking at the code for this is the algorithm. We first take in the inputs, then we take in the total prices, then we take in q, then we first initially sort the price of drink, then we run the loop q times, and at each q iteration we will use binary search to find the index from this array, and then we will output that value. So looking at the code for this, first I've taken in the input n, then I've initialized all the shops and their prices, then I have sorted those shops in ascending order, Then I've taken in queue, and I'm running the queue for queue. I'm running the loop for queue number of times, and at each loop I am taking in the coins I have, and I'm finding the index which I need, to output. So in C++, upper bound can be used to run binary search, which returns the index of the element. So I'm using this to find the index. You can also write the code for binary search to get the index. But if you write the code for binary search from scratch, you need to output index plus 1, as upper bound returns the output in the form of 1 to n, and we need to output it between 1 to n and not between 0 to n minus 1, which is the normal 0 convention. So based on the convention, you need to output index or index plus 1 based on the programming language you are using. So I would submit this code. As you can see, my answer gets accepted. My answer did not get accepted here on the first try, as I was doing the brute force approach initially, which where I was traversing each element to find the ring. So which gave me time limit error, as it exceeded the given time. So thank you for watching, guys. Do like and share the video, and subscribe to my channel for more such content on competitive programming or web development or machine learning. Do mention in comments down below what type of video you would like to see next, and what would you like me to improve as well. Thank you for watching. Do subscribe to the channel.